Hey guys, welcome back to my channel. So today we're going to do practice questions for perpendicular lines. I've taken 6 questions, 3 from HR and 3 from H. We're going to practice the different types of questions that can come for perpendicular lines. And this is one of the topics that is expected to come in the paper 2 for 2HR and 2H, which is going to happen on Wednesday. So if you have any questions regarding anything, please leave a comment and I'll try to help you out. So let's start the first question. So it says ABCD is a trapezium with AB parallel to DC. A is the point with the coordinates negative 4, 6. B is the point with coordinates 2, 3. And D is the point with coordinates negative 1, 8. The trapezium has one line of symmetry, and the line of symmetry intersects CD at point E. Work out the coordinates of the point E. So for this, let's first draw a rough sketch for the trapezium. This is the trapezium, point A, point B, C, and D. We have one line of symmetry. That means AD will equal to BC. And this line of symmetry will intersect your midpoint of the line AB and DC. So the line of symmetry is intersecting CD at the point E. So this is E. And let's call this M. So we have the coordinates for A, which are negative 4 and 6. B is 2, 3. And D is negative 1, 8. We don't have C, we don't have E, we don't have M. But since M is the midpoint of AB and E is the midpoint of CD, we can definitely figure something out. So let's begin with finding the midpoints of AB, which is M. So midpoint of AB. So that's going to be negative 4 plus 2 divided by 2, comma 6 plus 3 divided by 2. For the midpoint, we add the x coordinates and divide by 2 and the y coordinates and divide by 2. So that's going to be negative 2 divided by 2, which is negative 1. 6 plus 3 is 9. 9 divided by 2 is 4.5. So this is your coordinates of M, which is the midpoint of AB. Now, after this, we can find the gradient of the line AB. Why? Because the line of symmetry is perpendicular to the line AB. So if you have the gradient of line AB, we can use that to find the gradient of line of symmetry. And since the line of symmetry is passing through point M, so using that, we can create an equation for the line of symmetry. So gradient of AB, that's going to be 3 minus 6, y2 minus y1 over x2 minus x1. So 2 minus negative 4. That's negative 3 over 2 plus 4, negative 3 over 6, which is negative 1 over 2. This is the gradient of AB. If you remember, if we have two perpendicular lines, gradient of line 1 times the gradient of line 2 would equal to negative 1, which means gradient of line AB times the gradient of the line of symmetry would equal to negative 1. Hence, negative 1 over 2 times gradient of the line of symmetry equals to negative 1, which means the gradient of the line of symmetry is going to be negative 1 times negative 2 cross multiply, which is positive 2. So now that we have the gradient of the line of symmetry and we have the point on the line of symmetry, which is negative 1, 4.5, we can create an equation for it. So equation of line of symmetry. Now that's going to be y equals to mx plus c. We have the value of x and y, which is negative 1 and 4.5. We have m, which is 2. We substitute these into the equation to find the value of c. So 4.5 equals to 2 times negative 1 plus c. 4.5 equals to negative 2 plus c. 4.5 minus -2, and that's going to give us 2.5 for C, which means y equals to 2x plus 2.5. That is the equation of the line of symmetry. Now, next thing what we can do is that we know that the line of symmetry is intersecting the line DC as well. And AB is parallel to DC, which means whatever the gradient is of the line AB, that is the gradient of the line CD. And if they have the same gradient and we have a point for that line, which is point D, we can create an equation for that. And then if we solve this equation and then line of symmetry equation simultaneously, that can help us in finding the coordinates of E, because the line of symmetry is intersecting the line CD at point. So that is the point that is common between both the lines. So if we now find gradient of AB is -1/2, hence gradient of CD is also going to be -1/2 because they are parallel lines. Now again, y equals to mx plus c. Point D has the coordinates of -1 and 8. And gradient is -1/2. We substitute this into the equation to find the value of C. 8 equals to -1/2 times -1 plus C. 8 equals to 1/2 plus C. 16 equals to 1 plus 2C. 16 minus 1, 15. So 15/2 is C, which is 7.5. So y equals to -0.5x plus 7.5. This is your line CD. This is your line of symmetry. So now we solve these two simultaneously to figure out what the coordinates of E are. Y equals to 2x plus 2.5 and y equals to -0.5x plus 7.5. We can put both the equations equal to each other. So 2x plus 2.5 equals to -0.5x plus 7.5. Select the like terms on each side. So 2x plus 0.5x equals to 7.5 minus 2.5, which is 2.5x equals to 5. X equals to 5 divided by 2.5, and that is x equals to 2. Then for the y coordinate, what we'll do is we'll put x equals to the equation. So y equals to 2 times 2 plus 2.5. That's 4 plus 2.5 and 6.5. So coordinates of E are 2 and 6.5. And that is your final answer. And this question was for 6 marks. And the next question says that the straight line equation y minus 2x equals to 7 is the perpendicular bisector of the line AB, where A is the point with coordinates j7 and B is the point with coordinates 6k. We have to find the coordinates of the midpoint of the line AB. So if this straight line is the perpendicular bisector of the line AB, so let's say this is AB, and this is the straight line, this is the perpendicular bisector. This is y minus 2x equals to 7. What you need to remember is that if they use the word perpendicular bisector, that means it's passing through the midpoint of the line AB. So this is the midpoint of the line AB, and this line is passing through that. And that's exactly what they're asking us to find. So perpendicular lines, like we discussed before, the product of the gradients will equal to -1. So first, let's begin to find the gradient of the line y minus 2x equals 7. So y minus 2x equals to 7. Let's convert this into slope-intercept form. Y equals to 2x plus 7. M is the coefficient of x. C is the constant. So M is 2. So if M1 is 2, that means M2 is going to be 2 times M2 equals to negative 1, and M2 is negative 1 over 2. So this is the gradient of AB. Now, they said that A is the point with coordinates J7 and B is the point with coordinates 6K. So what we can do is we can create an equation for the line AB, and then we can create another equation for the gradient of the line AB. And then we can solve those two simultaneously to figure out what the value of J and K are. And then using that, we can find the midpoint as well. So the negative 1 over 2 would equal to K minus 7 over 6 minus J. Cross multiply, negative 6 plus J equals to 2K minus 14. J minus 2K equals to negative 14 plus 6, which equals to negative 8. This is one equation. Now we also know that the line y minus 2x equals to 7 is crossing the line AB at the midpoint of AB. So let's create an equation for the midpoint of AB. And then what we can do is we can substitute those midpoints in the equation y minus 2x equals 7 because the midpoint does lie on that line. The midpoint of AB is going to be J plus 6 over 7. J plus 6 over 2 and 7 plus K over 2. Just check. Yeah. So X of M is J plus 6 over 2 and Y of M is 7 plus K over 2. Actually, we don't need to add these brackets. Okay. So now we have the equation y minus 2x equals to 7. So the y can be replaced with 7 plus k over 2, and x can be replaced with j plus 6 over 2. Once again, the reason for this is because the line y minus 2x equals 7 is passing through the line AB through the midpoint of the line AB, which means that point does lie on the line. So we can substitute the coordinates for M, the midpoint of AB, in the equation and create another equation in terms of just J and K. And then we can simultaneously solve that with J minus 2K equals to negative A. So that's 7 plus K minus 2J minus 12 equals to 14. K minus 2J minus 5 equals to 14. And K minus 2J equals to 14 plus 5, which is 19. This is your second equation. So first equation is J minus 2K equals to negative 8. So you can make J the subject, and negative 8 plus 2K can be substituted in the third equation. So sub 3 in 2. So that's K minus 2 times negative 8 plus 2K equals to 19. K plus 16 minus 4K equals to 19. K minus 4k equals to 19 minus 16, which is negative 3k equals to positive 3. K equals to 3 divided by negative 3 and k is negative 1. So j was negative 8 plus 2k, negative 8 plus 2k. So negative 8 plus 2 times negative 1, that's negative 10. So x of m is going to be j plus 6 and 7 plus k. So j plus 6 over 2 is negative 10 plus 6 over 2, negative 4 divided by 2 is negative 2, and y of m is going to be negative 1 plus 7 over 2, which is 6 over 2, and that is 3. This is your midpoint of the line AB. And that's your answer. Point of AB, negative 2 and 3. So far you must have realized the main thing you need to remember, that if two lines are perpendicular, the product of the gradients will always equal to negative 1. If you have a perpendicular bisector, the perpendicular bisector is passing through the midpoint of the line that it's perpendicular to. If it's just perpendicular, then it's just perpendicular to the line. It's not passing through the midpoint. Unless, state in the question. Then it says ABC is a triangle in which angle ABC is equal to 90 degrees. P and Q are integers such that the coordinates of A are P10, the coordinates of B are negative 1, negative 5, and the coordinates of C are 8Q. Given that the gradient of AC is negative 6 over 7, work out the value of P and the value of Q. So let's first draw the right angle triangle. A, B, C. Angle B is 90. P is A is P10, B is negative 1, negative 5, and C is 8Q. Given that the gradient of AC is negative 6 over 7. So what we can do is first we can create an equation using the gradient of AC, which will be in terms of P and Q. So negative 6 over 7 equals to 10 minus Q over P minus 8. Cross multiply. Negative 6 times P minus 8 equals to 7 times 10 minus Q. Before I continue with the question, there is one thing I would like to highlight over here. Some people believe that, we can put the denominators equal to each other and the numerators equal to each other, and we can figure out the value of P and Q. But do you think that would be the case over here? Because it's a 6 or 5 mark question. And if we're just able to directly find the value like this in one step, the question will make sense. So please don't make that mistake that, you put the numerator equal to each other and the denominators equal to each other and figure out the value of the unknown through that. That's not going to be correct. You will lose all marks for this question. So please don't make that mistake. So now we expand the bracket. Negative 6p plus 48 equals to 70 minus 7q. Negative 6p plus 7q equals to 70 minus 48, and that equals to 22. So this is one equation. Now we know that the gradient of AB times the gradient of BC is going to be negative 1 because both lines are perpendicular. So let's create more equations. So gradient of AB, that's going to be 10 minus negative 5 over P minus negative 1. That's 15 over P plus 1. If you're wondering why I didn't do negative 5 minus 10 and negative 1 minus P, that would also be correct. You just have to pick your x1, y1 and x2, y2. that doesn't matter, like whether you're making A x1 y1 or B x1 y1, but you have to make sure that A is x1 and y1, not x1 and y2. So that is very important. One point will be x1 y1 and the other would be x2 y2, not the other way around. So this is the equation of gradient of AB. Now we do the same for BC. So that's going to be Q minus -5 over 8 minus -1. Q plus 5 over 9. So for this, 15 over P plus 1 multiplied by Q plus 5 over 9 equals to -1. So that's 15 times Q plus 5 over 9 times P plus 1. Cross multiply again. 15Q plus 75 equals to -9P minus 9. 15Q plus 9P equals to -9 minus 75. And that equals to -84. This is your second equation. Now we solve this and the other one simultaneously. So that was -6P plus 7Q equals to 22. And 9P plus 15Q equals to -84. Now to solve them simultaneously, it's best that we use the elimination method because that's easier and less time consuming. We have to make the coefficients equal. So what we can do is we can times this by 9 and this by 6. That's -54P plus 63Q equals to 22 times 9, which is 198. And then again, 54P plus 15 times 6, that's 90Q equals to 84 times 6, -504. We add the two equations to cancel out the P. So that's 63Q plus 90Q equals to 198 minus 504. So 198 minus 504 is -306. And this is going to be 153Q. So Q is -306 divided by 153. That gives us -2 for Q. Now for P, we can just substitute the value of Q into either of the equations. So we can say that -6P plus 7Q equals to 22. Replace Q with -2. That's -6P minus 14 equals to 22. -6P equals to 22 plus 14, which is 36. So P is 36 divided by -6, which is -6. So that's your value of Q and P. Then another type of question that you can get is that write an equation of a line that is parallel to the line with equation y equals to 7 minus 4x. So as I said, parallel lines have the same gradient. So y equals to -4x plus 7. Now your gradient is -4, not 7. They have purposely written 7 before -4x to confuse you. A lot of people make this mistake that they believe that the first number is going to be the gradient. So they would pick 7 as the gradient, which is incorrect. Negative 4 is the gradient because the gradient is always the coefficient of x, not the constant. So m is negative 4. So you can create any equation as long as the gradient is negative 4. You can write y equals to just negative 4x. You can write y equals to negative 4x plus 2, anything, as long as the gradient is the same. Then it says that the line passes the points with coordinates negative 3. Then it says the line passes the points with coordinates negative 3, 1 and 2, negative 2. Find an equation of the line that is perpendicular to line L and passes through the point with coordinates negative 6 and 4. So if it's perpendicular, that means we need to find the gradient of the line L first. Gradient of L, that is negative 2 minus 1 over 2 minus negative 3, which is negative 3 over 5. So gradient of L2 would be negative 3 over 5 times M2 equals to negative 1. So M2 is negative 1 times negative 5 over 3, which is positive 5 over 3. This is your gradient of the line that is perpendicular to L. So it passes through negative 6 and 4. So we use this point and this gradient to find the equation. Y equals to mx plus c. 4 equals to 5 over 3 times negative 6 plus c. 4 equals to negative 10 plus c. 4 plus 10 equals to c, which is 14. So y equals to 5 over 3x plus 14. We want the equation in this form. So we multiply all of the terms by 3. So 3y equals to 5x plus 42. And 3y minus 5x minus 42 equals to 0 is our final answer. The next question says in straight line L1 has equation 2y equals to 6x minus 5. And the straight line L2 is perpendicular to L1 and passes the point 9, negative 1. Find an equation for L2. So once again, let's find the gradient of the line L1. 2y equals to 6x minus 5. Make y the subject. Y equals to 6x over 2 minus 5 over 2. Y is 3x minus 5 over 2. So M1 is, which is the gradient of line 1, 3. Then L2 is perpendicular to L1. So if they're perpendicular, which means 3 times M2 would equal to negative 1. And M2 is going to be negative 1 over 3, which is the equation, which is the gradient of line L2. Now, L2 is passing the point 9, negative 1. We have to find the equation. So y equals to mx plus c. Y is negative 1, m is negative 1 over 3, and x is 9. Let's solve this to find the value of c. So negative 1 equals to negative 3 plus c. Negative 1 plus 3 equals to c, that is 2. So y equals to negative 1 over 3x plus 2. We want the equation in this format, so the constant on one side. So y plus 1 over 3x equals to 2. This is your equation of the line L2. Then this question says that ABC is an isosceles triangle with AB equals to AC. So let's draw it. A, B, C, AB equals to AC. B is the point with coordinates negative 1 and 5. C is the point with coordinates 2, 10. M is the midpoint of BC, which means this is also your line of symmetry for the isosceles triangle because AC is equal to AB. Find the equation of the line to the points A and M. So we have to find the equation of this line of symmetry. So for this, first, let's begin finding the coordinates of M. midpoint of BC, that's going to be 2 plus -1 over 2 and 10 plus 5 over 2. 2 minus 1, so that's 1 over 2, that's 0.5. And 10 plus 5, 15 divided by 2 is 7.5. After this, we should find the gradient of the line BC because the line BC is perpendicular to line AM. So gradient of BC, y2 minus y1 over x2 minus x1. So that's 5 minus 10 over -1 minus 2. That's -5 over -3, which becomes positive 5 over 3. Now, like we discussed previously, product of the two gradients will equal to -1 if the lines are perpendicular, which means 5 over 3 times m2 equals to -1, and m2 is going to be -3 over 5. We have the point which lies on the line AM. We have the gradient, so we can create an equation. Equation of AM is going to be y equals to -3 over 5x plus c. Y is 7.5. -3 over 5 times 0.5 plus c. That's 7.5 equals to -3 over 10. 7.5 plus 3 over 10 equals to c. That's 7.8. So y equals to -3 over 5x plus 7.8. Either rewrite the fraction as a decimal or a decimal as a fraction. So if we rewrite 3 over 5 as a decimal, that's going to be 0.6. So y equals to -0.6x plus 7.8. They want the answer in terms of py plus qx equals to r, where they're all integers. So y plus 0.6x equals to 7.8. Let's convert them all into integers. So that's going to be 10y equals to 6x plus 78. We can further simplify it by dividing it by 2. So that's going to be 5y plus 3x equals to 39. That is your final answer. This question says that ABCD is a kite with AB equals to AD and CB equals to CD. B is the point with coordinates 10, 19. D is the point with coordinates 2, 7. Final equation of the line AC. If we draw a rough representation of our kite, A, B, C, D. AB equals to AD and CB equals to CD, which means the line AC is the line of symmetry of the kite. If it's a line of symmetry, that means it's also perpendicular to the line DB. And if AC is a line of symmetry because it's equally dividing the shape into equal lengths, which means this M point is your midpoint of the line DB. So you need to be very familiar with your shapes that once you're drawing a rough sketch, you automatically figure out, what you need to find instead of wasting time on finding extra things. So we have the coordinates of B, which is 10, 19. We have D, that's 2, 7. We have to find the line AC. So for that, we need the grade of the line AC and the coordinates for M, because that's easy to find. So M we can easily find, which is the midpoint of DB. So that's going to be 2 plus 10 over 2 and 7 plus 19 over 2. That's 12 over 2 and that's 26 over 2, which is equal to 6 and 30. Now for the gradient of DB, That's going to be 19 minus 7 over 10 minus 2, which is 12 over 8, and that is 3 over 2. So that means 3 over 2 times m2 would equal to -1, since the line AC and DB are perpendicular. So m2 is going to be -2 over 3. We have the gradient, we have a point, we can easily find the equation. Equation of AC, which is y equals to mx plus c. That's 13 equals to -2 over 3 times 6 plus c, which is -4 plus c, and that's 13 plus 4, which is 17, which means y equals to -2 over 3x plus 17. They want the equation in terms of py plus qx equals to r. So multiply everything by 3. So that's 3y minus 2x plus 51 and 3y plus 2x equals to 51. That is your final equation. And with that, we're done with the questions for perpendicular lines. If you would have noticed, like, the steps are pretty much the same. For you to develop better understanding, I would strongly recommend that draw a rough sketch of the shape that's described in the question, write the points and all. And also remember another thing, I just realized that I have to highlight that. When you make the rough sketch, that does not mean that, these lines are like horizontal and vertical like I've drawn. Like, the orientation can be different because we're not drawing these sketches on a grid, we're just roughly drawing them. So we don't know what their exact placement is going to be on the grid. So please do not assume that, if this is that means to the left-hand side, so it's going to be that many units up or down like that. That's incorrect. Do not make that mistake. And other than that, the shapes are very much similar. You're getting a trapezium, you're getting a kite, you're getting a triangle. That's it. These are the main shapes that get repeated more frequently. And you need to know how to find the midpoint, you need to know how to find the gradient, you need to know that perpendicular lines, when you multiply the gradients, it equals to -1. In parallel lines, the gradients are equal. So these are the basic rules you need to remember. And if you know these, you will easily be able to solve these questions and get your grade 8 or 9. If you have any questions regarding anything, leave a comment below and I'll help you out. And in the description, I'm attaching the PDF for the compilation of questions for perpendicular lines. It includes questions from H and HR, paper 1, 2. So feel free to practice these questions and I'll attach the marking scheme by today as well. And also don't forget to watch the second version of my printed paper for 2025 for paper 2 H and 2 HR. I'll be uploading those on Sunday. So best of luck with your exams.